I hope all of you are doing good. Let's start today's chapter, linear graphs. Introduction. In our previous class, we learned that how ordered pairs of two numbers are drawn on a system of two lines perpendicular to each other called coordinate axes. We had also learned how to plot points on a graph and to draw graphs of linear equations in two variables x and y. In this chapter, we shall study more deeply these concepts and shall learn how to solve graphically the intersection of two linear equations. Okay? Coordinates. In day-to-day life, we come across several situations when we need to describe the position of an object. For example, we may want to know our seat in examination hall, our seat in cinema hall, etc. In mathematics, we need a quick and easier way to describe the position of a point or object. In previous classes, we have learned to read and draw a number line. If we draw a number line and rotate it 290 degrees in anti-clockwise direction such that point O coincides, we call these lines as horizontal and vertical lines as shown here. Okay, this is vertical, this is horizontal axis. Okay, so here horizontal axis, that is XOX dash. Okay, this is called x-axis. Okay, this is x-axis. OX and OX dash are called positive and negative parts respectively. Okay. And vertical line YOY dash is called y-axis. OY and OY dash are called positive and negative parts respectively. Okay, this is x-axis, this is y-axis, this y dash, x and x dash. This is positive, this is negative, this is positive and this is negative. Okay, the plane along with x-axis and y-axis is called the Cartesian plane or coordinate plane. The coordinate axis, that is x-axis and y-axis, divide the plane into four equal parts which are known as quadrants. Okay, so these are the quadrant 1, 2, 3 and 4. So starting from OX and then moving anti-clockwise, the quadrants are named as 1, 2, 3 and 4 quadrants respectively as shown in this figure. So in figure 17.3, which is given on the next page, right? Point A is 5 units to the right of the origin and 3 units up from the origin, and this point is referred to as a 5, 3. So 5 is called the x, okay, 5, 3. So 5 is what? It is called the x coordinate or abscissa, and 3 the y coordinate or ordinate of A, and the pair of numbers 5, 3 denotes the coordinates of A. Okay, as here you can see figure 17.3. So in figure 17.3, point A is 5 units to the right of the origin and 3 units up from the origin. Okay, and this is up. And this point is referred to as 5, 3. 5 is called the x coordinate or abscissa and 3 the y coordinate or ordinate of A, and the pair of numbers 5, 3 denotes the coordinates of A. Okay. Note, if a point lies on x-axis, its coordinate is in the form of x, 0, and if a point lies on the y-axis, its coordinate is in the form of 0, y. That is, on x-axis, y coordinate is 0. And on y-axis, the x coordinate is 0. Okay. Example 1, here coordinates of the points are given P, Q, R, S, T and U in the given Cartesian plane. Also write the quadrants in which these points lie. Okay. So here are the points given. The coordinates of given points are follows. As you can see here, P is minus 6, 2. Q is minus 3 and 4. R is 4 and 5. Here you can see S is 6, 3, T is equals to minus 5 and minus 3, U is equals to 5 and minus 2. So points R and S lie in first quadrant, point P and Q lie in second quadrant, point T lies in third quadrant, and point U, as you can see, lies on fourth quadrant. Okay. Now quadrants. The coordinate axes divide the plane of the graph into 4 regions that we call quadrants. Number 1, the region X, O, Y is the first quadrant. Here X and Y both are positive. 2, the region Y, O, X dash is called the second quadrant. Here X is negative while Y is positive. 3, the region X dash, O, Y dash is called the third quadrant. Here both X and Y are negative. The region Y dash, OX means this region is called the fourth quadrant. Here x is positive while y is negative. Remember that, okay? So example 1 is we have to plot the points on a graph paper. Okay, so you will take first a graph paper like this. This is your x-axis, this is origin 0, 1, 2, 3, 4, 5. Okay, -1, -2, -3, -4. This is your y-axis. This is x, this is x dash. 1, 2, 3, 4. -1, -2, -3, -4. Okay, and then you will plot all the points in this graph, okay, with the help of a graph paper. Exercise 17.1, what you have to do, you have to plot the points on a graph paper which are given here, right? Next, graphs of linear equations in two variables. To draw a graph of a linear equation in the variables x and y, we follow the steps given below. Number 1, first make a table of values. Usually, we choose 3 values of x and find the corresponding values of y from the given equations. We normally take only the integral values of x. 2, we plot these points on the coordinate plane of the graph paper. 3, then join any 2 points and find that the third point lies on it. We will find that graph of a linear equation in 2 variables is always a straight line. Okay, for example, we have to draw the graph of the equation which is given 2y minus x plus 3 is equals to 0. So, we will write this equation as minus x plus 2y plus 3 is equals to 0. We can also write it like this, and 2y is equals to what? X minus 3, okay, and y is equals to x minus 3 by 2. Now, we will put the value of x here and then we will get the value of y. Okay. If we put value of x as 1, so what will you get? So, you will make a table here. Okay, we will make a table here, x and y. Okay. So, we had this value y is equals to x minus 3 by 2. If you put the value of x as 1, so what will you get here? 1 minus 3 is by 2, minus 2 by 2 is what? Minus 1 we will get. Okay. Now, put the value of x as what? Minus 1. Minus 1 minus 3 upon 2. Minus 4 by 2 and the answer is minus 2. So, you will get the value of y as minus 2. And if you put the value of x as 3, so what will you get? 3 minus 3 by 2, that is 0 by 2, that is 0. So, here you will get the points of x and y. Now, what will you do? You will plot the graph, okay, and after plotting you will get a straight line, okay. So, you know, whenever you plot the points of a graph of a linear equation, you will find that it is always a straight line, okay. Exercise 17.2, question number 1, solve the following equations graphically. You have this equation x plus y is equals to 1. So, you can write it as 1 minus y, x is equals to 1 minus y. Now, make a table. You can put any value of your choice. For example, if you put the value of here, if you put the value of y, you will get the value of 1. If you put the value of y as 0, so 1 minus 0 is 1, you will get 1. If you put the value of y as 1, so 1 minus 1 is what? 0, so you will get the value of x as 0. And if you put the value of y as minus 1, so what will you get? 1 minus minus 1 is 1 plus 1, that is 2. Okay, so you can put any value of your choice, right? Next, graphical solution of simultaneous equations. For the solution of a simultaneous linear equation in 2 variables x and y graphically, we proceed in the following manner. Number 1, draw the graphs of the 2 given equations after obtaining the table of values for x and y. 2, in the graph, note the coordinates of the point of intersection of 2 lines drawn. And number 3, the coordinates of the point of intersection in the solution of the given equations. Okay. Example is solve the following simultaneous equations graphically. So here we have given this equation 2x minus y minus 2 is equals to 0. Okay, and this is, here we have given 2 equations. Okay. So what will you do? We will find the table of values for each equation we have. So first equation is 2x minus y minus 2 is equals to 0. Okay. 2x minus 2 is equals to y, or so here what will you do? You will make table x and y. You will put the value of x and you will get the value of y. If you put x as 0, if you put here 0, so 0 minus 2 is minus 2. If you put value of x as 1, so what will you get? 2 into 1 is 2, 2 minus 2 is 0. So you will get value of y as 0. And if you put value of x as 2, 2 into 2 is 4, 4 minus 2 is 4 minus 2 is 2. Okay, now another equation is this, x minus y minus 1 is equals to 0, or you can write x minus 1 is equals to y. Now make the table x and y. If you put the value of x as 0, 0 minus 1 is minus 1. So value of y is minus 1. If you put the value of x as 1, 1 minus 1 is 0. Okay. If you put the value of x as 2, 2 minus 1 is 1. Okay. And now you will plot the graph. Here you can see the point of intersection is 1 and 0 here, because these 2 points are same in both the equations, right? So the solution is x is equals to 1 and y is equals to 0, right? Exercise 17.3, solve the following simultaneous linear equations graphically. Okay, 1 to 5. Okay, so let's solve these equations graphically. X minus y is equals to 0. Okay, this is your first equation. So x is equals to y. Now value of x, if the value of x is 0, value of y is also 0, value of x is 1, value of y is also 1, value of x is minus 1, value of x is also minus 1. Okay. Now take another equation which is x plus y is equals to 2 and x is equals to 2 minus y. Okay, or you can say, okay, now make the table. Here you will put the value of y. If you put the value of y as 0, you will get a 2. If you put the value of y as 1, you will get 2 minus 1 as 1. If you put the value of y as 2, you will get a 0. Okay, now you will draw the graphs. Okay, you can put any points here, you can put value of your choice. Okay, things to remember. Number 1, two numbers, lines x, o, x dash and y, o, y dash drawn horizontally and vertically respectively on a graph paper form a coordinate system. X, o, x dash is called the x-axis and y, o, y dash is called the y-axis. 2. If P is any point on the coordinate system and we draw PM perpendicular to x, o, x dash, then we have OM is equals to x is called the x coordinate of abscissa of P. PM is equals to y is called the y coordinate of the coordinate of P, and coordinate of P is written as P x comma y. 3. By sign convention, the x coordinate is taken positive to the right of the origin and negative to the left of origin. The y coordinate is taken positive above the origin and negative below the origin. 4. We can graphically represent a linear equation by making a table of values and then plotting the points and joining them. Number 5. We can solve a pair of simultaneous equations in two variables x and y, first graphically representing them and then finding out their point of intersection. Students, I hope you have understood this chapter. Now you will do practice of plotting graphs.